Okay, today we are going to be talking about section 12.5, the binomial theorem. Let me just get this lined up so it's not so crooked on your screen for you. Okay, something to know if we don't know this already is the factorial symbol. It's basically a number with an exclamation mark after it. And what this simply means is that for any value n that's greater than 2 or equal to 2, but it has to be an integer, n factorial is equal to n multiplied by n minus 1, multiplied by n minus 2, etc., all the way down to 3 times 2 times 1. So if we had 5 factorial, that's 5 times 4 times 3 times 2 times 1. Two numbers by definition, 0 factorial is 1, and 1 factorial is 1. So there's just ones you need to know. But for what we need today, we're going to be using the factorial symbol. And we are told that if j and n are integers, with n being larger than or equal to j, then we can use this symbol, and it stands for combinations. If there are n elements, and we take j at a time, so it is defined, that value, as n factorial divided by j factorial are multiplied by n minus j factorial. So we're just going to try plugging this in. Basically, what this is giving us is the number of combinations that we can take, given that we want this many elements. So what this symbol is read as 4 taking one at a time. So by definition, this is 4 factorial multiplied by 1 factorial multiplied by n minus j, so 4 minus 1 factorial. Let's just write this out. The numerator, we have 4 factorial. Denominator, 1 factorial is just 1. And then 3 factorial. And 4 factorial is by definition 4 times 3 factorial. And in the denominator, well, a 1, I can ignore that. 3 factorial we have here. So now these cancel out, leaving us with 4. And again, this is really telling us how many combinations that we can make. So if we have 4 elements, let's say A, B, C, and D, how many different ways can I take one of those at a time? Well, I could take one. I could take A, I could take B, I could take C, or I could take D. There's 4 ways I could take one at a time. This next one, this is a combination of 5 taking 3 at a time. And again, by definition, this is 5 factorial divided by 3 factorial multiplied by 5 minus 3 factorial. And what we try and do is we're going to write this out. We'll still leave the 5 factorial in the numerator. And in the denominator, I've got 3 factorial and 2 factorial. Okay, so the top, what I'm trying to do is write this out until I get something I can cancel with the denominator. So 5 factorial is 5 times 4 times 3. And since I have a 3 factorial in the denominator, I'm not going to continue going with that. I will stop there. Because 3 factorial is the same as 3 times 2 times 1. And I have a 3 factorial and I have a 2 factorial. So the 3 factorials will cancel. 2 factorial is just 2 times 1. So 2 goes into 2 once, 2 goes into 4 twice. So we are left with 5 times 2 divided by 1. So that is just a 10. Okay, 7, a combination of 7 taking 5 at a time. So again, 7 factorial divided by 5 factorial multiplied by 7 minus 5 factorial. And we're going to try and simplify this. So the numerator, I'm going to simplify until I get to one of these values. And 7 minus 5 is 2, so 5 factorial is bigger. So I'm going to rewrite 7 factorial as 7 times 6 times 5 factorial. And again, I'm stopping there because I have a 5 factorial in the denominator. And this is 2 factorial, which that just gives me a 2. Because 2 times 1. I guess I could write it, but we don't really need it. So the 5 factorials will cancel. 2 goes into 2 once, 2 goes into 6 3 times. So we are left with 7 times 3 in the numerator, and in the denominator we have a 1. So the combination of 7 taking 5 at a time is 21. Now this last one, 50 taking 35 at a time, again, this is 50 factorial divided by 35 factorial, and 50 minus 35 is 15 factorial. Well, I don't really want to write all of these out till I get to 35. That's going to be a big number. So we can do this on our calculator. And we will use the math button, then right arrow over to probability, and we're going to choose option number 3. So the math button, right arrow over to probability, and option 3 is my combination. So N taking, instead of J, they use the letter R here. So on this one, I have 50 items, and I want to take 35 of them at a time. And I want to see how many different ways I can do that. 2.25 e to the 12th. So this is scientific notation. And this is going to be 2.2508 multiplied by 10 to the 12th. So a very big number. And again, this is why we use the calculator to do these kind of combinations. And again, we got that by going math, right arrow to probability, and then choose option 3, NCR, which is for combinations. Okay, some useful ones. If we have n taking 0 at a time, that's always going to equal 1. N taking 1 item at a time is always going to equal n. So if I had 5 items in my set and I want to see how many different ways I can take one of them at a time, well, there's 5 different ways. If I have n items and I want to take n minus 1 items, there are again going to be n different ways of doing that. And finally, if I have n items and I want to take n at a time, there's only one way to do that. So these are some useful ones to know. You could always write them out, but it saves you some time if you just remember those. Okay, if we turn our paper over, here is what is called Pascal's Triangle. And the numbers produced from this formula are similar to Pascal's Triangle. So this is having 0 items taking 0 at a time. The second row is having 1 item taking 0 at a time, having 1 item taking 1 at a time, having 2 items taking 0 at a time, 2 items taking 1, 2 items taking 2, etc. So all these symbols are just for our combinations. And the numbers, the values we get, I'm showing over here. So there is only one way to take 0 items. If I only have 1 item, there's one way to take no items, and there's one way to take 1. If I have 2 items and I want to take 0, there's only one way to do it. If I have 2 items and I want to take 1 at a time, well, there's 2 ways to do that. So here are the numbers going across for each of these rows. And notice that we've got some numbers here at the side. Our J value, that's the not the numerator because it's not a fraction, but the top number, the number of items in our, so we've got 0, 1, 2, 3, 4, etc. And this triangle, while it doesn't look very impressive, gets utilized quite a bit. And again, it's called Pascal's Triangle. And one of the things I want you to notice here is that every single row is found by summing together 2 items from the row above it. So this 3, if I add the 1 and the 2, I get 3. If I add the 2 and the 1, I get 3. And we will always have 1s going along the edges here. So this row here, where J was 4, 1 plus 3 gives me 4. 3 plus 3 gives me 6. So the sum of the 2 items above gives you the number in the row below it. Likewise, here's a row when J is 5. I get this 10 by 6 plus 4 gives me 10. And notice that this is very symmetrical. The left side looks just like the right. Okay, so why do we care about that? The reason we care about Pascal's triangle and the reason we use it is it makes doing some expansion much easier. So if we have this binomial, x plus a, and a is a real number, raised to the power of n, and n is a positive integer, well, I can tell you the coefficients for every term without having to go through and multiply it out. And the way we find those coefficients is that whatever this exponent is, that is my j value, and then we're going to have 0, 1, 2, 3, etc., all the way up till we get to n. And what we're multiplying this by is, first one is x to the n, a to the 0. The second term is x to the n minus 1 times a to the first power. The next term would be n taking 2 at a time, a squared times x to the n minus 2. And you would continue up until you got to the very last term, which is n items taking n at a time, and the x would be to the 0 power, the a would be raised to the nth power. This is another way we can write it. It's the sum of, that's what the sigma means, the sum of, going from j equals 0 all the way to n, of n items taking j at a time, x raised to the n minus j power, multiplied by a raised to the j power. That looks like a lot of stuff. So let's try it out and see how this actually works. So if I want to expand this, that means 3y plus 2, I want to multiply out times itself 4 times. Well, instead of having to do all of that multiplication, I can use this theorem to find all the different terms that are involved. So the first term, well, let's go ahead and do this. 3y represents my x, and 2 is my a value. So 3y is what I'm going to be putting in wherever there was an x, and wherever there is an a, I'm putting a 2. So the first term is going to be the n, which is 4, taking 0 at a time. Okay, and then it's going to be multiplied by x, so that's 3y, raised to the power of n. In this case, that's 4. Plus 4 taking 1 at a time of 3y raised to the 4 minus 1 power, so that's 3, multiplied by the a value raised to the first power, plus 4 items taking 2 at a time. See, I tried to make that a fraction. X, so 3y raised to the second power, and the a value also raised to the second power, plus 4 items taking 3 at a time of 3y to the first power multiplied by a to the third power, plus our final term in this expansion, 4 items taking 4 at a time of 3y to the 0 multiplied by 2 to the fourth power. And so the one thing I always want to make sure you notice is that the x term starts at the n value and continues to get smaller by 1 every time. So 4, 3, 2, 1, 0. The a value, and we can go ahead and put it in here, starts off at 0 and increases by 1 every time until it gets to the nth power. So I think that's just helpful to keep in mind. And now let's see what, that looks like just a lot of stuff right now. So 4 taking 0 at a time. Well, that's going to be 1. 2 raised to the 0 power is 1. So this is really just 3y to the fourth power. Plus 4 taking 1 at a time, well, that's 4, multiplied by 3y cubed, multiplied by 2 to the first power. Okay, so all that's multiplied together. Here we have 4 taking 2 at a time. So 4 taking 2 at a time, that's 4 factorial over 2 factorial times 2 factorial, multiplied by 3y squared and 2 squared is 4, plus 4 taking 3 at a time, that is just 4, multiplied by 3y, multiplied by 2 to the third, and 2 to the third is 8, plus 4 taking 4 at a time, that's just a 1, and 3y to the 0 power, that's just 1, so it's really just 2 to the fourth, which is 16. So again, let's simplify this a little bit. 3y to the fourth. So 3 is raised to the fourth power and y is raised to the fourth. 3 to the fourth is 81, y to the fourth, plus, so 3 cubed is 27 times 4 times 2. So 27 times 8 is 216, y to the third. And 4 factorial over 2 factorial times 2 factorial, that's just a 6. So this is really just a 6 right here, multiplied by 3 squared, so that's multiplied by 9. 6 times 9 times 4 is 216, y squared, plus 4 times 3 times 8. Well, 4 times 3 is 12 times 8. So 4 times 3 times 8 is 96, y plus 16. And there is my expanded binomial. So I've taken a binomial, meaning there's 2 terms in it, and multiplied it out without having to do all that multiplication. So let's try another one. Turn to the next page. And again, we're using that same formula, so let's keep that handy if we want to look at it. So I want to find the coefficient of x to the 7th in this expansion. And again, my x term, it's not just the x, it's the 3x. And my a value is a -1. So when we have a negative in here, we've got to be very careful. Negatives raised to odd powers will be negative. Negatives raised to even powers will be positive. So we will definitely have to utilize that information. Okay, so let's start writing this out. So if I was to expand this, I would have 10 items taking 0 at a time of 3x to the 10th and -1 to the 0, plus 10 taking 1 at a time of 3x to the 9th, multiplied by -1 to the first, plus 10 taking 2 at a time of 3x to the 8th, multiplied by -1 squared, plus 10 taking 3 at a time of 3x to the 7th, -1 to the third. Okay, I'm not going to write out the rest of them because this is the term that I'm asked to find the coefficient of. So there's no need to look at any others here. So 10 taking 3 at a time, that's 10 factorial over 3 factorial times 10 minus 3, 7 factorial, multiplied by 3x to the 7th, multiplied by -1 cubed. Okay, so let's write this out. 10 factorial, that's going to be 10 multiplied by 9, multiplied by 8, multiplied by 7 factorial. And again, I'm stopping at 7 because I have a 7 factorial in the denominator. 3 factorial is 3 times 2 times 1 times 7 factorial. So the 7 factorial, oh, and I left out these ones. I also have 3x to the 7th, and 3 to the 7th is 2,187 x to the 7th, and -1 to the 3rd is -1, right? Because it's to an odd power. So my overall answer here, 10, oh, let's see if we can cancel things. 2 goes into 10 5 times, 3 goes into 9 3 times. So what I really have now is 5 times 3 times 8 times 2,187 times -1. and only a 1 left in the denominator. Well, I'm going to put that in the calculator, and when I multiply all those out, I get negative 262,440 x to the 7th. But I was asked to find the coefficient. So the coefficient is negative 262,440. So that is the answer. That is the coefficient of x to the 7th. Okay, so let's take a look at this next one. We're asked to find the 7th term of this expansion of y plus 3 to the 8th power. Okay, so if we were to expand this, which term is that? We could write them all out, or we could do this. We could have y to the 8th, we'll have y to the 7th, y to the 6th, y to the 5th, y to the 4th, y 3rd, y squared, y, and then a constant. So 1, 2, 3, 4, 5, 6, 7. That's the term I'm really looking for, is the y squared term. And if we keep in mind that n, taking j at a time, a to the j power, x to the n minus j power. Well, if I want the 7th term, that's the y squared, so that's going to have to be 8 taking 6 at a time, because 8 minus 6 gives me the 2, so that will give me the squared term there. And the value of this is going to be the a value, 3, raised to the 6th power, multiplied by y to the n minus j. So 8 minus 6 is 2. So this is going to be my 7th term in this expansion. And 8 taking 6 at a time, that's 8 factorial over 6 factorial times 2 factorial, multiplied by 3 to the 6th power y squared. 8 factorial, let's actually write it underneath, is 8 times 7 times 6 factorial. And again, I'm just going until I have 1 in the denominator, so I can cancel, multiplied by 2. So my 6 factorials will cancel. My 2 goes into 8 4 times. Oh, and I left off this guy. 3 to the 6th power is 729 y squared. So I have 4 times 7 times 729 divided by, not divided by 2 because I've canceled the 2 out. That gives me 20,412 y squared. And again, so to find the 7th term, I had to think about which term that's going to be, what that coefficient was, and go ahead and do all the expansion there. Okay, how about this last one? It's just second to last one. We just want to expand this completely. So x minus 3 to the 6th. Again, we've got a negative, so we have to be a little bit careful of that. And we want to expand this completely. So here we go. We're going to start off with 6 taking 0 of x to the 6th, negative 3 to the 0, plus 6 taking 1 of x to the 5th times negative 3 to the 1st, plus 6 taking 2 of x to the 4th, negative 3 squared, plus 6 taking 3 of x to the 3rd, negative 3 to the 3rd. And again, remember, the exponents for the x term get smaller and smaller each time by 1. The exponents for the constant, or the a value, go up by 1 every time. Plus 6 taking 4 of x squared, negative 3 to the 4th, plus 6 taking 5 at a time of x to the 1st power, negative 3 to the 5th, plus 6 taking 6 of x to the 0, negative 3 to the 6th power. Sorry, I ran out of room there. Well, 6 taking 0 is 1. That's 1. So that's just x to the 6th here, plus 6 taking 1 at a time. That's 6 times a negative 3 times x to the 5th. So we'll have to do one more row here. 6 taking 2 at a time, that's 15. And I'm just plugging this in the calculator to get these values right now. X to the 4th, negative 3 squared is 9, a positive 9. 6 taking 3 at a time is 20. X cubed, negative 3 cubed is negative 27. Plus 6 taking 4 at a time, well, the numbers are going to start to go down, so that's going to be 15. X squared, negative 3 to the 4th is 81. Plus 6 taking 5 at a time, that's just a 6. X. Negative 3 to the 5th is going to be negative 243. Plus 6 taking 6, that's just a 1. X to the 0 is 1, so it's just negative 3 raised to the 6th power, so 729. So let's just simplify the remaining terms here. So we've got x to the 6th, not plus this next one. 6 times negative 3 is negative 18, x to the 5th, plus 15 times 9 is 135, x to the 4th. 20 times negative 27 is negative 540, x cubed. Plus 15 times 81 is 1,215, x squared. Plus, not plus, minus negative 243 times 6 is negative 1,458, x plus 729. That is that binomial expanded now. So let's take a look at one last problem. Okay, a little bit more complicated here, but we can do it. Find the coefficient of x to the 0 in the expansion of x minus 1 over x squared raised to the 9th. Okay, so this is my x value. My a value is negative 1 over x squared, and n is 9. So let's go ahead and start writing this out. So I'm going to start off with 9 taking 0 of x to the 9th. My a value, negative 1 over x squared to the 0, plus 9 taking 1 at a time of x to the 8th, negative 1 over x squared to the 1st power, plus 9 taking 2 of x to the 7th, multiplied by negative 1 over x squared, plus 9 taking 3 at a time of x to the 6th multiplied by negative 1 over x squared to the 3rd power, plus 9 taking 4 multiplied by x to the 5th, negative 1 over x squared to the 4th, plus dot, dot, dot. The reason I'm saying that is let's look at this term right here. I've got x to the 6th multiplied by an x 1 over x squared to the 3rd. Sorry about that. Okay, so how do we deal with this at this point? Well, what we need to do is negative 1 cubed is going to be negative 1 because negative 1 cubed is an odd power. But x squared to the 3rd power, I multiply the exponent. So the denominator is going to be x to the 6th, multiplied by x to the 6th. That gives me x to the 0. So this is the term that we want right here. So we're going to go ahead now and just worry about this term. So I've got 9 taking 3 times x to the 6th multiplied by negative 1 x squared cubed. So what this gives us, still 9 taking 3, this gives me x to the 6th multiplied by negative 1 over x to the 6th So I've just raised this to the third power. When I multiply these together, the x, the 6 cancel, leaving just a negative 1. So I have 9 taking 3 of negative 1. Okay, so 9 taking 3, that means it's 9 factorial over 3 factorial times 6 factorial times a negative 1. 9 factorial, I'm going to write that out, so that's 9 times 8 times 7 times 6 factorial over 3 times 2 times 6 factorial. And again, 3 times 2 is just 3 factorial. The 6, times negative 1. And now I'm going to go ahead and just simplify where I can. So 2 goes into 8 4 times. 3 goes into 9 3 times. So I'm left with 3 times 4 times 7 times negative 1 divided by 1. And that gives me a negative 84. So that is the coefficient of the x to the 0 term. And there you have your answer. Okay, good luck. Ask me if you have any questions. Otherwise, go ahead and get started on the homework. You've got this.